Good afternoon, class. We are looking at pre-calculus trigonometry practice test or exam review number 1, module 1 covering chapters 5 and 6, chapter 5, trigonometric functions, chapter 6, periodic functions. We're going to look at the first couple of sections. And so here's the first question. Answer the following. Convert 315 degrees to radians, convert 9 pi over 5 radians to degrees, convert 3 radians to degrees. So it's basically degrees versus radians. So a couple of things we want to mention. Number one, d over 180 is r over pi because half a revolution pi is equal to 180 degrees. So that's one way to calculate this. Simply put in what you have and what is missing and take it from there. Having said that, so 315 degrees, you can multiply it by pi over 180. Or put 315 degrees here and then cross product gives you that 7 pi over 4. 9 pi over 5, so that would be the radian and degrees is missing, or 9 pi over 5 is the times the reciprocal of that 180 over pi. So the pi's cancel each other. 180 and 5 cancel each other. And 9 times 36 is 324 degrees. 3 radians, we do exactly the same thing. And we get 540 over pi precisely. Roughly, we go with a couple of decimals, 171.89 degrees. Find the exact value of 14 pi over 3. Let's see what we need to do. First of all, a periodic function repeats itself at some regular interval. Trigonometric functions are all periodic. The period for all of them is 2 pi for tan, and therefore cotangent is only pi. And in this case, when we write sine of theta plus 2k pi equals sine theta, that means k, of course, is an integer. So having said that, you can see that this number, 14 pi over 3, is larger than 2 pi. So you can take 2 pi out. How many? As many as possible to bring it to a first complete revolution from 0 to 2 pi. So having said that, you can look at this concept as well, which means we should know the common arcs such as sine of pi over 4 square root of 2 over 2, cosine square root of 2 over 2, tan is 1, cotangent is 1, cosecant and secant are the reciprocal of those. So cosecant, the reciprocal of sine, and secant is the reciprocal of cosine. So having said that, notice that 14 pi over 3 is 12 pi over 3 plus 2 pi over 3. And the reason we go with 12 pi over 3, 12 divided by 3 is 4 pi, or 2 times 2 pi. So we go 2 complete revolution, and then we come back at 2 pi over 3. Okay, that's the idea, everybody. And so sine is positive in the first as well as the second quadrant, and that one is square root of 3 over 2. It's one of those common arcs we should know. Okay, so pi over 3 is square root of 3 over 2, and so is 2 pi over 3. Bear in mind that pi over 3 acts as reference arc. All right, let's look at this case, everybody. Name the quadrant that contains the terminal point of the arc. T equals 2, meaning 2 radians, and justify your answer. Let's refresh everyone's memory as far as the concept. Number one, this is a unit second, x squared plus y squared equals 1, or equals 1, and every point has coordinates x, comma, y, and in other words, cosine and sine. So x is cosine and y is sine. So over here is 0 degrees or 0 radians, 90 degrees or pi over 2, 180 degrees or pi, 270 degrees or 3 pi over 2, and the coordinates, of course, 1, 0, 0, 1, and so on and so forth. So roughly, we're going to go with 3.14 to represent the pi, so we have an idea how it's going on. And of course, reminding everybody of some of those values for cosine and sine. So x squared plus y squared equals 1. And a point has coordinates x comma y or cosine t and sine t. Sine is y, cosine is x, and the rest of them you can figure out. For example, tangent is y over x, or sine over cosine. Cotangent is x over y, or cosine over sine, and the rest of them follow in the same manner. So having said that, we said this is 0. This is pi over 2. This is pi. This is 3 pi over 2, and we come back to 0, 2 pi, and pi is about 3.14. So pi over 2 is 1.57, roughly. Pi is 3.14, roughly. Remember, pi is 3.14159, and it continues indefinitely. 3 pi over 2 is about 4.71, and 2.1 is almost 6.28. Therefore, in the first quadrant, t is between 0 and 1.57. In the second quadrant, it's between 1.7 and 3.14. In the third quadrant, t is between 3.14 and 4.71, roughly. And finally, in the fourth quadrant, between 3 pi over 2, which is 4.71, and 2 pi, which is about 6.28. Now, where is this number 2? Between 1.57 and 3.14. Therefore, it gives us quadrant 2. So that's the justification for that. Very straightforward. Now, part B of the question, find the exact value of cosecant 11 pi over 2. Again, cosecant, just like sine, periodic with the period of 2 pi. So take multiples of 2 pi out. That's the concept. But to do so, I want to remind you of a couple of things first. Number one, if you have an angle, an arc, which is in the first quadrant, then the angular arc is the same as its reference angle. So standard angle is theta. Reference angle, they use theta prime. They also use theta sub r. They also use theta hat. These are different ways of writing reference arcs depending on the text that you're using. So what happens in the first quadrant, theta prime and theta are identical. In the second quadrant, by definition, by the way, the reference arc is the closest angle the terminal side makes with the x-axis. So over here, they are identical. Over here, the closest would be this one. So this would be the reference arc. Therefore, theta prime becomes pi minus theta, because this is theta. Remember that this is theta. In the third quadrant, the closest distance to the x-axis, in this case, the negative side, of course, of the x-axis, is here. And this angle, theta, is larger than pi, so theta minus pi. And finally, in the fourth quadrant is 2 pi minus theta, because this is the reference arc. Just to remind you of that. And again, whether this one or this one is a better and easier representation to understand, it's your choice. So again, this would be the reference arc for the first. This would be for the second quadrant. This would be for the third. This would be for the fourth, the red ones. So that's just understanding the reference arc. In this case, you really don't need much. Understand 11 pi over 2 is larger. So change it to 8 pi over 2 plus 3 pi over 2, because this is 4 pi, and basically it's the same as 3 pi over 2. Okay. Reference arc is pi over 2, but I mean, 3 pi over 2 is one of those quadrantal angles we should know. So it's 1 over sine, and we know sine of 3 pi over 2 is -1, so 1 over -1 equals -1. Whether you need this or not, I don't think you need it for quadrantal angles, but it's good to know. Determine the length of arc of a circle and area of a sector formed by the central angle theta if theta is 1/2 radians and r is 10 meters. Well, let's look at a couple of things. Number one, you have a circle. If you go around it, it's a complete circumference, 2 pi r. If you're interested in the area, is pi r squared. So this piece is called the sector. This has an arc length S, because C is 2 pi r, C is theta times r, S becomes r theta. Okay. Because area is pi r squared and the central angle is theta. Remember, pi, that means half of 2 pi. Complete revolution gives you the complete area. So half of 2 pi, it's half of r squared theta. So we justified how we come up with the arc length, r theta, with the area of this sector, half of r squared theta, and simply put, we plug in, and theta must be in radians. So S equals r theta, 10 times 1/2 or 5 meters. The units of the radius. Area, half of r squared theta. So half of 10 squared times 1/2, as you know, this is 100, and divided by 4 is 25 meters squared, the units of area. If central angle theta is 60 degrees, the radius is 5 feet. We use the same formula, but of course, 60 degrees, we should know it's pi over 3. There's really no need to change it by using the multiplication by pi over 180. We should know that it's a common arc. S equals r theta, so 5 pi over 3 feet. Now pay attention to this. This is an exact answer, and you shouldn't change it to an approximation unless they ask you. I'm giving you both. And if they ask you for approximation, let's say they said 3 decimals, you have to go to the fourth one to make a decision. Half of r squared theta is the area. Half of 5 squared, pi over 3. Of course, this is 25. 2 times 3 is 6. So 25 pi over 6. Exact answer, roughly 13.090 square feet, units of area. Each wheel of a car with a radius of 15 inches makes 3 revolutions per second. How fast is the car moving in miles per hour? And that means linear velocity. And of course, when we calculate it becomes this, and then we change it accordingly. So having said that, first and foremost, let's see what's given, and then we take it from there. The radius is 15 inches. 3 revolutions per minute. Revolution, a complete revolution, means 2 pi radians. So when we say 3 revolutions per second, okay, that means omega, okay? We are looking at omega, but omega is 3 RPS in this case. So linear velocity V is distance over time, or S over T. Angular velocity omega is angle over time, theta over T. 2 pi times RPM, normally revolutions per minute. It happened to be RPS. Okay, so we write that accordingly. And then the relationship V is S over T. Replace the S with R theta because that's the common arc. And if you separate it in the following manner, R times theta over T is omega, V becomes R omega. So in other words, the stuff that I have here, I wanted to quickly show you and remind you how we got there, the proof in essence. So now R is 15, omega is 3 RPS, and the velocity or linear velocity is missing in action. Bear in mind, revolutions per whatever they tell us. So V equals R omega. Omega is 2 pi RPS, so you have to multiply it by 2 pi. We get 2 pi times 3, which makes it 6 pi radians per second. Radians per second. And V equals R omega. 15 times 6, 90 pi. And the units would be inches per second. Why inches per second? Because R has units of inches. And of course, this is radians per second. Now, roughly becomes 282.7 inches per second. This is 90 pi. And you want to keep it as 90 pi as an exact when we do the unit conversion all the way to the end, and then however many decimals they ask you. So what do we do? We want to go from 90 pi inches per second to whatever the number is to miles per hour. We know 1 mile is 5,280 feet. We also know 1 foot is 12 inches. We also know 1 hour is 60 minutes. 1 minute is 60 seconds. So 1 hour is 3,600 seconds. Therefore, I want to make sure we understand what's going on. I'm going to look at, for example, this one because we wrote this. You have a choice of putting this at top or this one at top. It's a unit conversion. Why are we putting 1 mile at top and not 5,280 feet at top? Because the final result is miles over hours. Miles should be at top. So whatever we do to numbers, we do to units. So take a look. This seconds cancels out these seconds. Inches cancels out inches. Feet cancel out. And so what you are looking at as far as the unit, so you have the number is 90 pi. Then you look up here 1 mile, 3,600. So we have nothing but the miles at top. You look at the bottom, this is gone. You have 12 times 5,280 hours. So the units are what you want. So the top is 90 pi times 3,600. The bottom is 12 times 5,280, and you don't have to write one. And you use many, many decimals, and then you put as many as they ask you. In this case, if we go with 3 decimals, 16.065 miles per hour. So that's pretty straightforward. If the length of an arc S is 50 inches in a circle with a radius of 6 inches, find the angle theta this arc subtends. In other words, if we First, let's write the given first. S is 50 and R is 6. Then if we look at this, okay, this S is given in essence. This R is given. And so what are we looking for? The angle theta. We know S is R theta. Therefore, theta must be S over R. 50 over 6. Precisely 25 thirds radians. What about the area? The area, half of R squared theta. Half of R squared, 6 squared, times theta, 25 thirds. Half, 6 squared, 25 thirds. Six squared is 36 divided by 3 is 12. So 25 times 12 divided by 2, or 6 times 25 is 150 inch squared. Units of the S or R, okay, squared, because you want the units for the area. Okay, the question is being repeated, so let's move on. Find the linear velocity of a cylinder with a 2 feet radian that is spinning at 40 RPM, revolutions per minute. So let's write the given. R is 2 feet. Omega is 40 RPM. V is missing. Omega is 40 RPM. You always must go to a different units. This is revolutions per minute. You have to go to radians. You must always multiply by 2 pi to go to radians. 2 pi RPM, that means 2 pi times 40. That means 80 pi radians per minute precisely. V is our omega, and we replace the R with 2 feet. Whenever you do application, it's really important to write the given first. So 2 times 80, 160 pi precisely. How many decimals? Whatever they ask you, always go with the precise. 502.65 feet per minute. Find the exact value of each of the remaining trigonometric functions, given tan theta is negative square root of 3 over 3, and we know sine is positive. So a couple of things. Number one, a unit circle, x squared plus y squared equals 1. If it's, and therefore P has coordinates x comma y, where x is the cosine and y is the sine. However, if it's not a unit circle, x squared plus y squared equals r squared p with coordinates x comma y or a comma b, then sine is y over r and cosine is x over r, and the rest of them follow in the same manner. Also, we should know in the first quadrant, everything is positive. In the second quadrant, sine is positive. and so is cosecant. In the third quadrant, tangent is positive, and so is cotangent. In the last one, in the fourth one, cosine is positive, and so is secant. And we have the following. Tan theta is negative, and sine is positive. The fact that tangent is negative puts us in the second or fourth quadrant. So this means second or fourth quadrant. Sine is positive for first or second quadrant. And therefore, the answer is second quadrant. Negative means quadrant 2. On quadrant 4, positive means quadrant 1 or quadrant 2. 2 is in common, and it's a common arc. Remember, tan of pi over 6 is square root of 3 over 2, so 5 pi over 6 becomes the same value but negative. So if we want to go with what we have here, tan is y over x. And if it's in the second quadrant, the x is negative. So take a look at the way we put it. Y over x is square root of 3 over negative 3. Why did we change the negative sign to the bottom? Because if this belongs to the second quadrant, it is the x coordinate that must be negative. X must be negative 3, y must be square root of 3, if we want to go that route. And so having said that, we can find the rest of them by looking at x squared plus y squared equals r squared. X is negative 3 quantity squared. Y is square root of 3 quantity squared. This becomes 9. This becomes 3. So they add up to 12. And so r is square root of 12 or 2 square root of 3. And r is always positive. Okay, everybody? R always positive. It's x and y that depends on the quadrant. One may become negative. So having said that, we know sine is what? Y over r. So we already have the y. We divide it by r and simplify as follows. This one becomes 1/2. If you want to go that route. Now, bear in mind, we are following this methodology, but this is a common arc. That means you really have to know the rest of them. Here's the rest, either going with this method or the fact that they are all common arcs. Again, I want to emphasize this one more time. This means theta prime, the reference arc, is pi over 6, which means all the trigonometric functions have the same value as the trigonometric functions of pi over 6. But depending on the quadrant, positive, negative, you have to make a decision on that. Find the exact value of each of the remaining trigonometric functions of theta, given that secant theta is 2 and sine is negative. Secant is 2. Secant is the same as cosine. Secant is positive in the first quadrant and the fourth quadrant. Sine is negative in the third quadrant and fourth quadrant. So 4 is in common. So secant is positive, sine is negative. That results in quadrant 4, and cosine, of course, is the reciprocal of that. All right. So there are different ways of approaching it. If we go with identity, sine squared plus cosine squared equals 1. Cosine is 1/2. Squared is 1/4. Subtract it from 1, you get 3/4. And sine becomes plus minus the square root of 3/4. Of course, sine is negative, so it's minus that, and it's minus square root of 3/2. By the way, class, this is common arc, okay? You should recognize this as positive 1/2 would be pi over 3 in the first quadrant, or 5 pi over 3 in the fourth quadrant. Because we've decided is this fourth quadrant, so this is 5 pi over 3. So right here, as a common arc, you should recognize the answer for theta as 5 pi over 3, and you can take it from there. You can go that route, but understand how we arrive at it. So in any event, we have just everything we want. So cosecant is 1 over sine, the reciprocal of this number. And negative 2 over square root of 3, you multiply by square root of 3 over 3, and you get minus 2 square root of 3 over 3. You are rationalizing. Tangent is sine over cosine. The denominator of 2 drops, minus square root of 3. And cotangent is, of course, the reciprocal of that, which is negative square root of 3 over 3. Now, the fact that we notice this is 5 pi over 3 will do the job, everybody, okay? And let's just write the synopsis of what we found right here for all of those trigonometric functions. And again, there are various ways of approaching it, everybody. Either way is fine. I just want to make sure that you're comfortable with the concept in general. Simplify secant of power 4 times cotangent of power 4. And again, I'm reminding you of the fundamental identities. Okay, secant, we can write it as 1 over cosine because it's a common arc and we know sine and cosine and so forth. Okay, again, it's one of those reciprocal ones. Cosine, we know it to be square root of 2 over 2. So this is 1 over square root of 2 over 2. Cotangent, we know it to be 1. And this means 2 over square root of 2 over square root of 2. All right, we want to simplify this expression. And to do so, we take a common denominator, which becomes sine theta cosine theta. So we multiply this one by cosine minus we multiply this one by sine. Again, taking a common denominator, adding fractions should not be any problem, everybody. So we're going to distribute, we get sine theta, cosine theta, we get cosine squared, we get minus sine theta, cosine theta, we get plus sine squared. These two cancel each other, we get cosine and sine squared. And as you know, they add up to 1. We can write them as 1 over sine theta times 1 over cosine theta, which results in cosecant theta, secant theta. Simplify sine squared plus cotangent squared plus cosine squared. And of course, just in case you don't have to move it, but let's move it to make sure we realize these two sine squared and cosine squared, they add up to 1. Okay, you don't have to move, and we should recognize that. And if you look at the Pythagorean identities, you should recognize this as cosecant squared. 1 plus cotangent squared is cosecant squared. Hopefully everybody remembers all these identities. So having said that, let's look at this example, cosine of power 6 secant of 13 power 6. So first and foremost, we keep this the same. This one, 12 pi over 6 is the same as 2 pi, so therefore it's the same as pi over 6. Remember the fact that trigonometric functions are periodic, and the period is 2 pi. So in general, you can add 2k pi. So a complete revolution can come out. So the first one doesn't change, but the second one, we change it to secant of pi over 6. As you know, cosine and secant are reciprocal. So this is 1 over cosine, and therefore they undo each other. They give us 1. Okay, that's the reciprocal, everybody. Now, in the case of tangent and cotangent, the period is pi. So over here, we have cotangent. Over here, plus pi or minus pi makes no difference, is cotangent. Same thing, plus 2 pi or negative 2 pi makes no difference, is cotangent, because pi is the period and k is any integer. So the integer here is negative 2. So they add up 3 cotangent theta. Graphs of the sine and cosine function. I want to remind you what we do. In the case of a sinusoidal functions, we go with 1, 2, 3, 4 arcs. That's the best way to go. So y cosine x, a complete cycle is between 0 to 2 pi. The key points would be the endpoint 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. And so we have 4 arcs. The domain is all real numbers. We have one cycle and we continue indefinitely. Range is negative 1 to 1. T is 2 pi. Amplitude A equals 1. And the same thing for cosine, of course. The key points are different. 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi. And note that sine and cosine are ultimately the same by a factor of pi over 2. They change. So sine x is the same as cosine of x minus pi over 2. If we have a sine omega x, then it changes the period to 2 pi over omega. So the basic one, t is 2 pi, amplitude is 1, but a sine omega xt is 2 pi over omega, and the amplitude is absolute value of a. Now, the general form, there are 2 ways to write it, either this way or a sine omega of omega x minus 5 plus b. And if we go with this one, the very first thing, you really should take the b out. So you notice that now if you put it in this format also. The period is 2 pi over b, or 2 pi over omega. Amplitude is the absolute value of A. There is a PS, or phase shift, of C over B, or phi over omega. C or phi less than 0. Phase shift is to the left, positive to the right. And note the midline of a function, okay, is the horizontal line midway between the maximum and minimum value of the function. For y equals sine theta, the midline is the line y equals 0, the horizontal axis, and in general, the midline y equals this. So this one is considered the midline. Okay, so that's the idea. And so in case they ask for midline, that terminology, it's referring to that. You add up the maximum value and minimum value, and you divide by 2, you find it. So find the amplitude, period, intercepts, and phase shift of this function. Sketch the graph of one complete cycle, reminding you of information about sinusoidal functions. And in this case, y equals -6 sine of pi thirds x plus 4. All right, let's see how we get this started. Obviously, the amplitude is absolute value of -6 or 6. T is 2 pi over omega. So 2 pi divided by the coefficient of x. When you divide by pi over 3, becomes 6. There is no phase shift. Okay, there's no number next to x. So you cut the period into 4 equal parts. The period is 6 divided by 4. You get 3 halves. And since there is no phase shift, you start from 0. You go to 3 halves. And then you keep on adding 3 halves. So 0, 3 halves, 3 halves to 3, 3 to 9 halves, 9 halves to 6. And now you put on the endpoints into the original function, and you find the y coordinates. So for example, 0, if you plug in, you get 0 here because x is 0, sine of 0 is 0, so the answer is 4. Again, we're looking at this one, okay, everybody? So having said that, three halves are 1.5. If I put 1.5 instead of x, divide by 3, that becomes pi over 2. Pi over 2, the sign is 1, so this becomes -6. I'm going to work on 4 at the end, and you can figure out the rest. If I put 3 here, I get pi, and sine of pi is 0, and so on and so forth. So one way to graph it is to completely ignore this for now. This is the shift up or down. It's positive. When you're done, it shifts up by 4 units. That's the idea, everybody. Okay. So 0, 0, 3, 0, 6, 0. Now 1.5, -6. 4.5, +6. And just come up with the graph, connect them. And If that was the function, you would go indefinitely on the left and right, you would be done. But that's not the function. We want this function. So you have to move it 4 units plus 4 units up. Which is also called the midline. So now, if I'm going to move it 4 units up, this becomes 4, this becomes -2, this becomes 4, this becomes 10, this becomes 4. Those are the points. Connect them, go indefinitely on both sides, and you're done. So very straightforward, everybody. Quickly, let's look at the second method. We already have the amplitude, we already have the t period. So we don't want to waste time on that because the phase shifter is none. We cut it into 4 parts, and those are the points that we need to look at. Now, if you put that into this function and then this function, so this function will result in those. Again, we've done that. But if you put it into the original function, that takes them up by 4 units. So add 4 to those y coordinates. You can go on the left also. So this is y equals 4. Put those 3 points. 0, 4. 3, 4. 6, 4. 1.5, -2. 4.5, +10. That's the thing. And again, look at the midline, okay? Maximum and minimum, they add them up. That's one way to write. In case you don't have it and you want to find it, add those to divide by 2 and you get y equals 4. Go indefinitely on both sides. Again, a second method for the sake of graphing, okay, everybody? We want to graph y equals 2 cosine 3x plus pi over 2. Again, we want to go through the whole thing and do one complete cycle. And we definitely, first and foremost, we take the 3 out. Okay, take the 3 out. Amplitude is 2. T is 2 pi over 3. The phase shift plus pi over 6 means the phase shift is negative pi over 6. We cut this into 4 equal parts. T divided by 4 is pi over 6. So it's important to know that you start from negative pi over 6 as the beginning, and then you add the period as the end. So you go from negative pi over 6 to negative pi over 6 plus 2 pi over 3. That's a complete cycle. And of course, this is negative 2 pi. If you want to add them up, this is 4 pi over 6. They add up to positive 3 pi over 6, which is pi over 2. So it's going to go from negative pi over 6 on the negative side to the positive side. So having said that, you start with negative pi over 6, and then you add pi over 6. So negative pi over 6 to 0, 0 to pi over 6, pi over 6 to pi over 3, pi over 3 to pi over 2. Those are the endpoints. So we want to put those into either this one or that one, makes no difference, and evaluate the y. So let's do minus pi over 6. If I put it here, it's easier. Minus pi over 6 cancels. This one gives us 0. And 3 times 0 is 0. Cosine of 0 is 1 times 2. This becomes 2. If I put 0 here, might be easier here. Pi over 2 cosine is 0. So that's 0. If I put pi over 6 here, and pi over 6 is 2 pi over 6, or pi over 3, and the 3, they cancel each other, becomes pi. What is cosine of pi? Negative 1 times 2. Again, maybe I show that because I want to make sure that you understand what I'm doing, and that means I showed those two. So if I want pi over 6, I put it here. Pi over 6 and pi over 6, I get 2 cosine of 3 pi over 3, which means 2 cosine of pi over 3 . No, pi. Which means 2 times, okay, let me just erase this actually. Looks bad. What is cosine of pi? Negative 1. So it's negative 2. So I've calculated the first 3 for you, 2, 0, negative 2. You can figure out the rest. And so if you plug the pairs, and let me erase my work so it becomes easy to follow. So plug in negative pi over 6 and the 2, 0, 0, negative 2 pi over 6, pi over 3, 0, pi over 2, 2, connect them. You can continue more, but in any event, just go indefinitely on the left and right. So more cycles in essence. Find the domain and range, intercepts, and vertical asymptotes of this function, y equals tan of 1/2 x. Reminding you, y equals tan x looks like that, which is sine over cosine. The period is pi. So there are two, for one complete cycle, there are two vertical asymptotes, x equals minus pi over 2 and x equals positive pi over 2. Vertical asymptotes in the general form has the format x equals 2n plus 1 over 2 times pi. Domain, okay, x can't be equal to 2n plus 1 times pi over 2. Ranges are real numbers. X intercepted, n pi is 0 because wherever sine is 0 and t is pi over omega or pi over b. So having said that, so when it comes to sine and cosine, we have amplitude. The other ones, we don't. So t equals pi over b or pi over 1/2, and it's 2 pi. So basically, you are expanding this. This goes from negative pi over 2 to pi over 2. Now it goes from negative pi to pi. That's all. So the domain, x can't be 2n plus 1 times pi. So over here, everybody, okay, if you pi over 2 changes to pi, okay? Range remains all real numbers. Vertical asymptote, this one change this to equality, becomes vertical asymptotes. So for one complete cycle, x equals negative pi and x equals pi. So those are the asymptotes, everybody. Let's plot a few points. Obviously 0, if you plug in is 0, minus pi over 2. Half of that is minus pi over 4 gives you negative 1. Pi over 2, half of that gives you pi over 4, and that's 1. And so plot those 3 easy points. And the graph looks like that. Very simple, everybody. Find the amplitude, period, intercepts, and phase shift of the function and sketch the graph of one complete cycle where y is 3 cosine pi x minus 4. So let's start by finding the amplitude is 3 because the absolute value of 3 is 3, and the period 2 pi divided by pi, or 2. There is no phase shift. Cut this into 4 equal parts. 2 divided by 4 is 1/2. Because there is no phase shift, we start from 0, 0 to 1/2, 1/2 to 1, 1 to 3/2, 3/2 to 2. And all we have to do, find the y coordinates. So, and there is a vertical shift of -4. So if we go directly to this one and say, okay, I'm going to put 0 here, class 0, I get cosine of 0, which is 1. 3 times that. Let me just show you. So I'm putting 0 here. 3 cosine 0 minus 4. Cosine 0 is 1. 3 times that is 3 minus 4 is -1. I hope you see that how we get -1 for the first one. If I put 1/2, cosine of power 2 is 0. So forget, you get -4. What about 1? Let me also show you 1. If I put 1 here, I get 3 cosine pi times 1 pi minus 4. 3 times cosine of pi is -1 minus 4 becomes -7. And you can figure out the rest of them, everybody. So plot those endpoints. This is y equals -4, 0, -1. This is the x-axis. Okay, 0. 1/2, -4, 1, -7. I'm sorry, this is 1. Okay, let me erase this because it's hard to see. 0 minus 1, 1 -7, 2 -1. And now those two pairs, 1/2 -4, 3/2 -4, put them together. And if they want, if they don't mention one complete cycle, you just continue indefinitely on both sides. Now, y equals cosecant pi x. We want to look at that one, everybody. And of course, we're going to go through the process of finding the domain range, vertical asymptotes, and so forth. And reminding you of cosecant x, which is 1 over sine x. X can't be in pi. The range is all real numbers except in between -1 and 1. So -infinity to -1 union 1 to infinity. It's an odd function. All trigonometric functions are odd except cosine, and therefore secant. T is 2 pi, vertical asymptote and pi, and so forth. So for this one, y equals sine pi x, we're going to graph. So if you want to graph cosecant, first go to sine. If you want to go with secant, first go to cosine. So ignore that and let's go to sine. And sine, the amplitude is 1. because there's no number in front of it, that means 1. And t is 2 pi over pi, or 2. There's no phase shift. We're going to cut this into 4 equal parts, and we get 1/2. So we're going to go from 0 to 1/2, 1/2 to 1, 1 to 3/2, 3/2 to 2. And we're going to evaluate them. For example, if I put 0 here, sine of 0 is 0. If I put 1/2, sine of power 2 is 1. So 1/2 gives us 1. If I put 1, sine of pi is 0, and you can figure out the rest. And so we have those 3 points, 0, 0, 1, 0, 2, 0, 0.5 or 1/2, 1, 3/2 or -1. And this is sine. This is not the answer we are looking for, but how do you come up with that? Flip over the graph. So it looks like that. So that is the graph we are looking for. The domain, x can't be n. Remember, x can't be n times pi. Remember, we came up with t to be 2. So half of that. Pi is half of 2 pi. So half of this number. Okay, half of this number is 1. So that's important to know. If you pay attention to that, you can figure out what you need to replace it with. Range, again, all real numbers except any number in between -1 and 1. So -infinity to -1 union 1 to infinity. Vertical asymptotes, if you look up here, x equals n times pi, so n times 1, or n. For 1 period, x equals 0, x equals 1, x equals 2. Those are the vertical asymptotes we are looking for, everybody.